Welcome to Intro to Conic sections. So we are now going to completely switch gears again and start in on something called conic sections. This is another topic that will be of use in Calc 3, even if it seems disconnected from the rest of the Calc 2 material. So the general idea and the reason these are called conic sections is if we take two identical cones and place them sort of on top of each other, point to point. So essentially we have a cone and then a cone on top of it. If we then intersect these cones with a plane, so essentially with a piece of paper, right? So if we slice through these cones with a plane, so a two-dimensional flat plane, the points of intersection form a conic section. So there are quite a few types of conic sections. So if you imagine taking a slice that's just sort of perpendicular to the cones and just cut through like this, the cut will wind up being a perfect circle. So one option is a circle. So we can get a circle of any radius if we raise or lower that horizontal plane. So you can get a circle of any radius by using a horizontal plane. If we happen to go straight through that tip of both cones, then we get just a point. So if we happen to take the plane that happens to just intersect directly at that point, we can get a point. If we take our sort of horizontal plane and tilt it slightly, And the intersection is sort of on a slant. I don't know how well I can draw this. But we get on a slant and we get what is called an ellipse. So it's not, it's longer in one direction than in the other. So an ellipse is formed by taking a plane with a slight slant. We can take a plane that runs directly down the side of the cone, and we simply get a line. So we can have a plane that simply runs down the side of the cone. And it gives us a line. So a line is formed by having the plane sort of run directly down the side. Of the cone. We can get two crossing lines if we say take something that goes straight down through the point. So if we take a plane that goes sort of straight down through our cone, that happens to also go through the point, we get crisscross lines. So we can get crossing lines or intersecting lines. And essentially, if we have a plane that goes through the central point that is steeper than the sides of the cone. Intersecting lines are formed by taking a plane that goes through the central point. With a steeper slant than the sides of the cone. We can also get a parabola if we take a plane that runs parallel to the sides of the cone. So if we pick a point that runs parallel to the sides of the cone, its intersection will be in the shape of a parabola. Oops, sorry about that. And so this is a parabola. So parabola is formed by taking a plane parallel to the side of the cone. And then it just cuts through the top part of the cone or the bottom part of the cone, and it doesn't go all the way across the cone. So it just is a parabola. It's not a closed shape. And then if we take a plane that's even steeper than the sides of the cone, and do not let it go through that central point. Sorry, that looks like it goes through the central point. So if we take this steep shape, then what we wind up getting is it kind of looks like a parabola up top, but it also gives us a piece in the bottom of the cone. So this is called a hyperbola. Hyperbola is formed by taking a plane which is steeper than the sides and does not go through the point, the central point or the tip. So it does not go through the cone's point or tip. Right. So essentially what we've seen is we have, if we take sort of horizontal planes, we get a circle. If we happen to drop those circles down to the, or that horizontal plane down to the, so it intersects at the point of the cones, we get a point. If we take our horizontal plane and give it a slight slant, by slight slant, I mean less, not as steep as the side of the cone. Then we get an ellipse. It goes all the way across to the other side of the cone. If we make that line have exactly the same slope, or if we make the plane have exactly the same slope, then we get a line if it runs directly down the side of the cones, or we get a parabola if it's shifted slightly up. If we take a plane that is steeper than the sides of the cone, if it happens to go directly through that intersecting point of the cones, then we get these crisscrossing lines. Otherwise, we get hyperbolas. Okay. So essentially what we have is we can get a circle. So in summary, our conic sections are we have a point. We can get a line. We can get intersecting lines. We can get a circle. We can get an ellipse. Parabola. And a hyperbola. So in this section, we will be focusing on the more interesting conic sections of an ellipse, a parabola, and a hyperbola. So this is sort of what we'll be focusing on in this section. Again, you will see these more in Calc 3. So we're at this point just learning various skills that can be useful in Calc 3.